Hello and welcome to the Global Science Show. I'm Nikki Thomas. I'm going to talk to you about how magnets help us sort our recycling. So here we've got plastics, we've got glass, we've got paper, we've got aluminium, we've got steel. I've got my chocolate orange, which is wrapped in foil. It's got a plastic outer casing and it's also got cardboard. How are we going to sort all that recycling? So you probably know that metals that are magnetic or materials that are magnetic will stick to a magnet. So plastic, no. Glass, no. Paper, plastic, copper, aluminium, cardboard, none of them are till I get to my steel can. Okay, that's easy. I can get rid of my steel can. How am I going to sort the rest of these materials? Well, to be honest, the glass, we normally crush it, it falls through a grid, so we can get rid of that. We're now left with papers, plastics, and our non-magnetic materials. What you might not know is that non-magnetic metals, like copper, like aluminium, they're really special. If a magnet moves past them, they do become magnetic temporarily. I'm going to demonstrate this. So I've got two rods here, two tubes here. One's plastic, one's copper. Copper is not magnetic. Let me just show you again. Doesn't stick. So first of all, I'll just show you, they're about the same length. I've got two ball bearings. These are made of steel. Steel is magnetic, but it's not a magnet. So if I touch them together, they're not going to stick. If I touch them to either side, they're not going to stick. So just to show you that they both fall through at the same time, I'm going to drop these through the tubes together. Do you hear that bang? Hopefully you saw right down on the bottom, in this tray here, you actually saw them fall. So now that you've practiced seeing where they fall, I'm going to drop two magnets. These are very strong magnets called neodymium magnets. I'm going to drop them, I'm going to release them at the same time from the top of the plastic tube and the top of the copper tube, and you will see one come through and a little bit later another one. So let's just listen out. Did you hear the two bangs coming down when it hit at two different times? That's because the copper turns into a temporary magnet as the neodymium magnet was falling through, and it was able to sort of attract the magnet, slow it down. And let me just prove that again. This time I'm going to drop one magnet through the plastic tube first, so you can see how it goes much quicker, and then through the copper tube, and you will see how much slower it goes. You see how much longer that took? And that way we're able to treat our non-magnetic metals as a magnet. If we've got moving magnets in our recycling plant, and we can actually get rid of things like our the bashed up actually aluminium tube, and leaving behind plastics and papers and things, and how they separate those is slightly different. So just one last clue, one last thing to think about. If my foil around my magnet is my chocolate orange is not magnetic, will I be able to release it? Will I be able to recycle that metal using my fixed magnet, my bar magnet, like I used with the steel, or will I need to use a moving magnet? And in the meantime, I am going to enjoy a nice piece of my chocolate orange and welcome you to our next guest, our next sort of presenter on the Global Science Show, which is Melogrammatical.